Hey guys, welcome to another video of Q Programming. Today we will be talking about chapter 4, which is Introduction to Problem Solving. So, before we get into this chapter, I first want to talk about why we are doing problem solving in computer science. Problem solving is essential because before you sit down to write a code, you have to think about the logic behind your code. You have to think about what you're doing in your code. And problem solving, in fact, helps us do that. Problem solving is a very general term, so to say, because it's done in a lot of places in the world. Like if you're solving a math problem, again, you're doing some sort of form of problem solving. If you're solving a numerical on any subject, you are solving a given problem. But computer science problems are not like numericals; they are different, very different. And the thing is, all languages follow the same fundamental base of commands. The syntax of the commands are different, but the fundamental base of all of them is the same. Like what are the things they can do. Just the syntaxes are different. So problem solving will actually help you get a general idea of how you can tell the computer a set of instructions in your own words so that later you can convert it to any language you desire. So let's get right into it. So now if you want to understand problem solving, you first want to know what are the steps to solve a problem. For problems. Right. So there are four main steps which are actually followed in problem solving, which is in this case we're specifically talking about a computer science problem. So the first thing you would want to do is analyze the problem, which you would actually want to do in any sort of problem. So to say, you will first collect the data you have, you'll first find out what you have to do, what are the inputs your program will take, what should it result in, what are the things you should avoid in your program that will not suit, etc. etc. All of those things need to be taken care of before you sit down to program. Right? So analyzing the problem is just your way of simply getting a feel of the problem. You don't have to write down anything, nothing. You just have to get a feel of the problem while you're analyzing. You just have to figure out what you're doing, what is the end result that my program should be giving after I've finished everything. The second step is developing an algorithm. So now an algorithm is basically a form of your own logic for a program, right? So you would want to develop an algorithm since it will help you create your own logic inside your head before you can go ahead and convert it to a programming language. And it's nothing but more than a plan in your own words, in fact. And these are much easier words than critical syntaxes that one will use in programming. It is just for your own reference so that while you're programming, you have something to refer to, something that will help you write down your code. So it's like writing a recipe, suppose. If you're making some form of Maggi, you would want to know a series of steps that you follow, right? Similarly, here you'll develop an algorithm, which is nothing but a series of steps in your own words. The third one is coding, which is what you will do. Now we will not be discussing that in this chapter because coding is something you will actually be doing all throughout this year in computer science. Coding is basically converting your developed algorithm after it's finalized into a programming language. In this case, I'm assuming a lot of you will be doing Python, if not all. So coding is what you will do after you have developed a fully finished algorithm. And lastly, we have testing and debugging. And before I get to that, I just want to say that coding is almost as important as developing an algorithm because without an algorithm, it will be tough to code. If you get into the habit of it, you might start finding it easy. But initially, if you try to code without having an algorithm in your mind, you will definitely get confused. That goes without saying. And testing and debugging is basically after your program is developed, you want to test to see if it works and you want to debug it. Debugging is when you make sure that no bugs are left in a program. Bugs are any faults or in a program that aren't running the way they're supposed to. They're not taking the right input. Something's wrong, right? So testing and debugging usually will help you figure out like, okay, what are the things going wrong in my program and rectifying it. And all four of these steps are actually very important, not just for the curriculum, and because when you actually go into like, if and ever you go into larger companies where you're developing, say, an application or a website, you will have a team, and in a team you can't just develop an algorithm alone and leave it as a set, right? Because if you just give your teammate a code of your program, say you were supposed to make a specific part of the app, you gave your code to your teammate, but your teammate may not understand your code because it's all just a bunch of critical words written here and there. They will get confused. So you can just give them your algorithm and your code so that they can actually understand what your code is doing at every line of the step, right? So this is the four steps to problem solving. Now let's get to algorithm because now we'll only be specifically talking about step two. So now algorithms. Now the question comes into play: why do we need algorithms? What is the need for an algorithm? So like I told you, a programmer, anyone who is writing programs, will have to develop a series of steps in their head before they can sit down to programming. So an algorithm can be done in whatever way you find easy, right? Whatever way suits you the best, you can just write your algorithm in that way and implement it in your program. That's the best way to go about it. And it is usually considered a first step to programming. And this is basically before you, like in technical terms, I would say, before you convert your series of steps to a high level language, you want it to be in your own words, in an easier language which can be understood by anyone, even if they're not familiar with the words of programming. So, first let's talk about what are the good characteristics of an algorithm. I mean, characteristics of an algorithm, sorry. So now a good algorithm should have a few things which must be necessarily to like they should be in that manner so that the algorithm is actually easy to understand for yourself and possibly for your team if you're working with a group of people. So the first thing you would want is precision. You want your algorithm to be as precise as possible. You don't want it crammed up with a million steps for no reason, right? You want it to be as easy to do, as easy to read, as easy to comprehend, and as easy to implement in your actual program. Everything, all your steps should be precisely stated or defined. Like if I suppose I'm making an algorithm which is not programming related, but it's suppose I need to boil water, right? So I won't actually tell everything like you will first take a glass, fill it with water, put it in the kettle, wait this long. Obviously, I won't write every single one of these lines. I'll just say, take a glass of water and put it. I won't say pour the water in your jug and put this much ml, put that here. Like, overcomplicating things is not something you would want to do in a good algorithm. And uniqueness. So this basically means that the results of each steps are uniquely defined and only depend on the input and the result of the preceding step, right? And thirdly, we have finiteness. Now, this obviously, as I said, you can't have an infinite algorithm. It makes no sense. Why would you want a program that you have to run forever? You want it to finish after a certain point. After it has conducted everything it needs to come to a stop. This is what finiteness means. You have to make sure that your program is finite and has a fixed number of steps, which after which it stops and ends. Fourthly, we have input and output. This is a very common abbreviation for this. I'm just going to write it here for now. You must have heard of IO, input output. So basically, you want to have a defined inputs that your program will take and a given output that the program will have. I will teach you how to take input and output in this very video. Now, while writing an algorithm, you have to identify a few things like just as I said, what are the inputs you're taking? What are the processes happening on that very input? And what are the results that are supposed to be created? And what is the output desired by the user? It's like a three-step process. Input, process, output. Like these three things are a necessary thing, even not just for programming, even a computer works on this fine. Like I'm typing on a notepad right now, right? The input is the keys that I'm pressing The process is that the computer is processing the keys that I am pressing, and it's converting them through ASCII values to a character. And the output it's giving is it's generating these words on my screen. So these three things, input, process, output, are necessary things that your program must have. It doesn't have to have all these, but these are things that are going to make it a good algorithm. Okay. Now there are a few ways to represent algorithms. The first way is flowchart. Right now. So now, a lot of you probably do know what flowcharts are. Flowcharts are nothing but a visual representation of that. The way you can visualize how your program's command is flowing through the program, how it's going here and there. So a flowchart is like, again, it's just a visual way of understanding your program. Of algorithms, sorry. And now, before we actually go ahead and start drawing flowcharts, I need you to know a few shapes. Like, I'm just going to show the shapes. I'm going to write them here as well. So, first thing, start end. Where would your program start and where would it end? So, for this, you have an oval, like this. It's called a Terminator block. It's an oval which you can draw in such a manner which indicates the start of a program or the end of a program. Okay. The next one we have is a process block. I'm just going to write oval here. I'm showing the shapes on the chart. And process. Process is actually represented by a rectangle and it's called the action symbol. This one right here. Process. Right? So I'm just right now telling you what each of the shapes do, and by process I mean anything that's performed. Like if I'm taking a number from the user and I'm multiplying it by 2, the process block is what's going to multiply by 2, nothing else. Suppose. Then we have a decision block, which is represented by a kite. So I'm gonna go back here. Kite. So like I said, a decision block is represented by kite. So here we are. And through a decision block, you're actually supposed to make 2 branches come out. One if the condition inside the decision block is true, and the other one if the condition inside the decision block is false. Okay. Then we have the input-output block, which is represented by a parallelogram. Which is like this. It's called the data block. I'm just going to write IO, which is input output. So IO block will either be printing something or it will be taking something from the user. Here it's only 2 main functions. And lastly, arrows, which are also part of a flowchart, which you can draw out of any one of these and connect it to any other. I will show you guys how you're supposed to go about drawing such flowcharts. So let's take a very easy example. Say I want to take the age of a user and I want to tell them how many years they have until the age of 18, until they turn 18, right? And if they're over 18, you should print you are over 18. So first example, let's take a number and say we want to cube that number, okay? So I will first put my start block right here, and okay, and I'm going to draw an arrow from it, and I'm going to cube a number taken by the user. So what I obviously need at this stage is an input, so a data block. I will now look at the way I'm writing it. I'll input num. So now num is a variable I have defined. Num is nothing but the input, the value that's going to be taken by the user will be stored in a variable that I have called num. That's what input num means. Then I will say, then I will say, then I will use a process block and I will say that q equals to num to the power 3. Now, this is actually what the symbolic representation of taking something to the power of something else is. These are just some arithmetic operators that I use in programming, or you can just do normally num into num, and I will connect this by an arrow, and I will just print this cube by going here and using the data block. I will say print cube, and then I will after this go ahead and stop my program using a terminator. So as you guys can see, I just developed a small flowchart for finding the cube of a number taken by the user and printing it back, right? So now, as I was talking about it before, these three things that you want to make in mind: input, process, output. I have done that in this very program. This is the input, this is the process, this is the output. Input, output, and flowcharts are the same block, which is parallelogram. So I hope it's clear how this is a very first like basic flowchart. So while I'm explaining, I would encourage all of you to try drawing these flowcharts as well, so that you get practice. So we'll be making a program on to check whether a given user is of legal age to drive or not. So the first thing I'll write is a start command. Then I will extend an arrow out of it, and I will put a inputting the age of the user. So basically, I'm checking for the user whether the user is eligible to drive or not. And the legal age for driving is 18. So I'm going to just write input, and I'm going to save it in a variable called age. Whenever I write a variable in front of input in pseudocode and algorithms, you should understand that the variable where my value is being saved, right? Then I will go down and I will put a decision block. Now, how you write codes in decision block is, suppose I want to check if the age is greater than 18. I will just say age greater than 18. Okay. If the age is greater than 18, I will create two branches. Yes or no. You can call it yes or no, or you can call it true or false, whatever you want, whatever suits you. Right? And then if true, it should print adult over here using the parallelogram. Otherwise, it should print and copy paste that down there. Not an adult. Okay. So what I have done here, and then I will just connect both of these to a common terminator, which is to end the program so it's stop. And I am going to go ahead and join this with this and with this. Great. So this is a small flowchart to check whether the given user is an adult or not an adult. Okay, now if I want to make further ramification in this program and I want to check whether the user is a teenager or not. So I will further now change this program. I will remove this and this, and I will create another nested condition. So now what's happening here is now it will check age greater than 13. And then it will create two conditions from this condition. Right? So first age greater than 13, true or false. And if it's true, then it should print teenager. Otherwise, it will print. Otherwise, it will print child. So I'm just going to take this and check. Then I'm gonna put a parallelogram here and write print child. And then all three of these, like this print adult, print um, child, and print teenager, all three of these will be connected to a common terminator. So the terminator comes here. And then I will connect this here. And I can connect arrows to other arrows which lead to a common block, like right here. These two arrows are connected to this, which both lead to the stop block. So in summary, what this program is doing is it's inputting the age. It's checking first if the age is greater than 18. If that's true, the program is going to be like, okay, adult, and it's going to stop. Otherwise, if the age is not greater than 18, it will false and it will say the age is greater than 30. If it does that, it will print teenager and stop. And otherwise, if that is also not true, it will print child and stop the whole group. So now this is a very good visual understanding. Now you can actually see how the program is flowing from, how the control is flowing from different places altogether. And just to make a program better, you can actually add greater than or equal to 18. That's the arithmetic operator for greater than or equal to. You just put an equal to in front of the greater than. In fact, I will write a list of arithmetic operators. That's a comparison operator. So arithmetic operators are plus for addition, minus, asterisk for multiplication, star for division. Comparison operators are greater than, less than, greater than or equal to, less than or equal to, and modulus. Modulus comes in after. So modulus is not the modulus you would expect in math. It's actually a way to determine the remainder when you divide the numbers. Like if I write 5 more 2, I will get 1. That will be my output, okay? So why this is happening is because now if you divide 5 by 2, you get 2, 1 by 2. And since 1 is the remainder, that's what is actually going to be finally printed. And I'm just going to write here. And here comes it's more. Anyway, so now these are the few operators you want to actually keep in mind while you're writing your pseudocode and algorithms, pseudocodes and flowcharts, so that you can write things that you want to depending on the program. Like suppose right now, since you're on flowchart, say I want to make a program to check whether a number is divisible by 2 or not. So how I will go about it is I will write the start block. I will take input from the user, which number I want to check, say input, and I'm saving that value in a variable called num. And then I'm going to write a process where I'm going to check the remainder of the number. So I'm going to say remainder, rem, short for remainder, is equal to num %2. So num %2 is actually going to check what the remainder when you divide by 2 is. Now, as you all might be familiar with this, if a number is even, it is always perfectly divisible by 2, meaning it will leave a remainder 0. Otherwise, it will leave a remainder 1. There is no other remainder any number divided by 2 can leave. Right? which is, so that is a good way to determine whether it's even or odd. So I just wrote remainder equals to this. And now, as you guys can probably guess, I will be using the decision rule. So I will write rem equals to 0. Now, double equals to is actually what you would use when you are giving a, like you're checking something whether it's equal or not. So you write this for equal to, okay? And see, now why this is uses a double equal to, because in programming, say I want to define a variable x and give it a value 5. So I write x equals to 5. This statement means that I have created a variable x which I'm giving a value of 5. But if I write x double equal to 5, this instantly means that I'm checking is x equal to 5 or not. So this can give me a true or a false, right? And this is nothing but an assignment to the variable. The value 5 is assigned to x, and the value here 5 is checked with x. Is x equal to 5 or not? Right? So this is basically the difference here. And the thing is, with assignment operation, with the assignment one, you can actually say x equals to x plus 5. Now, the thing is, let's say x is initially, I have defined it to be 2, and I write x equals to x plus 5. Now, what this means is, because if you try to look at it from a mathematical perspective, it will make no sense. X will cancel out 5 equals to 0. That makes no sense. But in programming, this actually does make a lot of sense, because if you think about it through assignment, I am assigning the value of x plus 5 to a variable x. So x plus 5 in this case will be 7, and I'm giving the value 7 to x. That makes sense. That makes a lot of sense. So if I print x, it will give me 7. So this is the main difference between comparison and assignment. Why we use a double equal to and single equal. Anyway, so if I write remainder equals to double equals to 0, I will pull down an arrow here, and I will take out two conditions from this. And if it's true, I will print and if it's not, I will print odd. So, and I will put both of these into a stop Terminator Block. Sure. Okay. So just zooming out a little bit, just so you can see the whole flowchart. This flowchart, in essence, what it's doing is it's gonna take the value of num from the user. It's gonna create a new variable remainder, which I've written REM for sure, as num mod 2. Num mod 2 will again check the remainder when the number is divided by 2. Now, since when a number is divided by 2, it can only have two possibilities, 0 and 1. Right? So if the remainder happens to be 0, that will ultimately mean that the number is even, otherwise the number is odd. So depending on that, I have created two cases using a decision block, and I have printed even or odd depending, and I have again stop method. I hope this is clear now. Now let's move on to another method of writing algorithm, which is called pseudocode. Okay, so now what is a pseudocode? Pseudocode is nothing but not real code. Like pseudo, as you know, like if someone says pseudonym, that's not the real name. So pseudocode is not a real code. It's just a code written for your reference, and it's just using it's going to use technical keywords, but it's going to be for your reference. It won't work if you try it on any specific programming language, right? So if I now, before we get into how to write pseudocodes, there are a few keywords one has to keep in mind. So that becomes input. Remember to write these keywords in capital. Compute, print, increment, decrement, else, if else, while, and true or false. So now these are a few keywords you want to keep in mind while writing pseudocode, because these are the keywords you will actually be using for your reference. Like suppose, let's say I want to find the volume of a cube where I take the side from the user. So I will write my pseudocode in steps. So I will first write step 1, input side as a variable. Step 2, volume equals to side times side times side. Step 3, I will print volume. Now this is a very simple program. So what this is doing is just nothing, it's just taking the side of the cube, it's finding the volume and printing it. So I have used these keywords right here. And before writing this, I will not write this directly. I will compute volume equals to side and side, and I will print volume. So as you can see, this is what the keywords you want to keep in mind while writing this good pseudocode. And if I take another, and the thing is, any pseudocode can be converted to a flowchart and vice versa. So if I want to convert the same program to pseudocode, I will see. I will input side. I will here I don't need to write compute, I can just directly write in the process block. And then I will just simply print volume. This is a very basic program, and I'm sure all of you are probably familiar with how to go about it at this point. And I will finally just stop. So now, even though this is a very basic program, the reason I wrote it here is because I want to now compare how is this different from writing a pseudocode. So if I open the pseudocode, we will see that in pseudocode, I did this in a very small amount of steps. I just needed 3 steps. But in flowchart, I had to write more things. I had to write start, I had to write stop, and I had to like choose the shapes precisely. But over here, the keyword is what matters. The keyword of input, compute, print, all of this, right? So now pseudocode actually have a lot more benefits than flowcharts when it comes to problem solving, because you want to make sure that I mean, what it does is that the advantage of pseudocode is that it will actually be similar to any programming language if you try any. But flowchart is a more visual representation. Flowchart is in fact better for understanding the program, but if you're actually going ahead and implementing it, pseudocode will be more beneficial for you. Over and above pseudocode, you can actually dry run to check if it's giving the right output. Like over here, if I want to dry run, what that will mean is I will just take a sample value to check how my program runs. Say if I take my side as 5, then I will now see. So side is a variable which is given the value of 5. Okay, and I will say compute volume equals to side into side into side. Okay, so volume equals to 5 into 5 into 5, which is 25. And then it will just print 125 on my screen. So that means, okay, my program is running fine. So pseudocode, you can actually do this. You can do this with flowchart, but it will be more hectic for you to do it. You can probably imagine why. So it's much easier in this way to actually just read pseudocode. And over and above, these are written in easy words. Like all of these words are not that hard to comprehend, right? And you can actually understand what it's trying to tell you. So even someone who's not done programming before can actually tell what your program is going to do. Alright. So now the main thing is I have covered how to write pseudocode and flowcharts. Now I'm just going to give you guys a few examples. I suppose the same thing I want to check whether a given user is eligible to drive or not. So I will say input age. Sorry. Now here I will put an if else condition. So if age is greater than 18, then I will write print added, else I will print not added, and that's it. It's a two-step program. It's a very easy one, so to say. And again, if I were to check whether the user is a teenager, I will add another if condition says else. This is very similar to the flowchart if you go ahead and compare it. If age is greater than 13, it will print teenager. In fact, I will go ahead and use the greater than or equal to operator. And else print child. Now, as you can see, I'm actually indenting my pseudocode because this is easier to understand for me. Like this whole if else condition is inside that one else, right? So now what this is doing is over here, if I see, it'll take the age of the user. If the age happens to be greater than 18, it'll simply just print it. So this is like a decision block, except it's like saying if this is true, I will do this, otherwise I'm gonna do that. Else it will go there and it will say if age is greater than 13, it should print teenager, else it should print child. Right? So now over here, very common mistake people can actually go ahead and make is remove the else and do this. This is a wrong program. Now why? If you dry run it, you will actually understand what I'm saying. Okay? Because the else condition will only be executed if everything before it in the if is the condition given in the if is false. Now why this program that I've written here is wrong? Let's try with the dry run. Okay? Say I entered my age as 7. So you know by logic it should print child. But let's see what the program will do. I will now read every line by line and understand what it does. So it will go to this line. It will say if age is greater than 18. Is age greater than 18? No. Okay, it's gonna go here. If age is greater than 13. No, it's not even going there. So else it will print child. Okay, it's going fine. So this printed child. That's okay. Now if I enter my age as 15. Okay, then it's gonna first check if age is greater than or equal to 18. No, it's not. Okay, it is greater than or equal to 13. Yes. Okay, 22. That's good. So it's working for any age before 18. Let's try an age after 18. Let's say if I give my age value as 24. So it's gonna first check if age is greater than 18. Yes. Okay, printing error. So it's gonna print error. And then it's going to check if age is greater than 30. 24 is greater than 13, so it'll print teenager. This is where it goes wrong because now what the computer understood by that is that it's just checking that value and comparing it with 13, right? So if it's just comparing it with 13, 24 is obviously greater than 13. So how to eliminate this is you want to create an else condition. Else condition means we have already ruled out the fact that our age is not greater than 18. Then it will go to the else, and then it can recheck another condition. Like so, if it checks if age is greater than 18, now it will only print AGA. It will not print teenage. Why? Because see, now let's say the age end is 24. So to check if age is greater than 18 is yes. Okay, fine, cool. So it will print AGA. So it will not go to the else in the first place now because before it was going into the other if condition because they're kept simultaneously. But here it will not. It will directly just not go there. It'll end the program. It will only go to the else condition if this given condition is false. I hope it's more clear. Now, you can like do like a lot of questions. Say Now I'm going to give another interesting question. Say I want to okay, now I'm going to talk about repetition. So say I want to print a number, I want to print the sum of 10 numbers taken from the user. Now you can't obviously create 10 variables and one interest. You can, but it will be a very lengthy program. So an easy way to go about it is to while what we talked about while. Okay. So now what this while will do is, I'll just give you an example to show how this works. So I will say, now I will first set some variables to 0, sum equals to 0, okay? If I need to do anything, I'll come back to it. Now step 2, repeat steps 3 to, I don't know till when my program will run, so I'm just going to do this. And I'm going to start writing step 3. Input number, step 4, sum equals to sum plus num. And so this should just run step 3 to 4. And I'm going to set count to 0. And I'm going to write so the way to write this is while count is less than or equal while count is less than or equal to 10, let me make this one, repeat steps 3 to 5. And why 5? Because I'm going to even click on, I'm just going to explain what I'm doing here. Just let me write the code down. Okay, so now what this code is doing is it's first creating two variables, sum and count, and it's setting them to 0 and 1. Okay, so now read what I've written. While count is less than or equal to 10, repeat steps 3 to 5. So now the computer will understand from this is, or what you're supposed to understand from this is, you have to read steps 3 to 5, these 3 steps that I've highlighted. What does step 3 input number? Step 4, sum is equal to sum plus number. I explained how this works. So the previous value of sum, the whatever input is taken will just be added to sum. And count will be incremented by 1. And then in the end it was to print the sum, whatever the value is. Now why I have done this is because, see, count is gonna start from 1. That's the initial value of count. And it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that way you can actually ensure that these 3 commands of yours will in fact run 10 times. And if you're able to do that, it will in fact print the sum of all 10 numbers, right? So count will take the value 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So while count is taking these values, these 3 steps will keep running, and sum is equal to sum plus num. We'll just add the value of num to the previous value of sum, and it will just keep going on and on like that. Say suppose I take my first number as 2, and initially the sum is 0, so sum is gonna become equal to 2. Then say my next number is 3, so my sum's value is gonna become 2 plus 3, which is 5. And so on and so forth. It's going to do this for 10 numbers and it's going to print the whole sum. So this is actually how repetition is done in pseudocode, and there's a way to do this in flowcharts as well. I'm just going to make this same program. And I'm gonna so now see how it's done in flowchart. It's done slightly it's done slightly differently. So what you want to do is you want to first, sorry, not this, you want to take the process block and you want to set the variables to the default value. So set count to 1 and set sum to 0. Okay, then we will put a condition. which is a decision block. Okay. Now I will say count is less than or equal to 10, and I'm going to pull out two conditions from it. And true and false. So if it's true that count is less than or equal to 10, it will input number and it's going to then it's going to add the value of num to sum by process. And if it's not, and see, now what's happening here is this goes here, and then this I can just extend an arrow back to this condition, like up here, right? So the second sum is equal to sum plus sum, it goes back here and checks if count is less than 10, and I need to make the value of count and then it's going to just go back here. And if count is now the second count reaches the value 11, it's going to go to the false part. And the second it goes to the false part, it should just print the sum. And at the end, use our target terminator to stop everything. So this is how you will go about doing repetition in flowchart. So again, what I did here, I started my program, I set the value of count to 1 and sum to 0. And count is less than 10 is the condition I gave it. If that is true, then it will input number. It's going to add the value of that number to sum, and it's going to increase count by 1. And it's going to check the condition again, count is less than 10. This time count will have a value 1 more than it was before. So it will keep increasing from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The second it reaches 11, this condition will become false, so it won't go here anymore. Instead, it will go here, print sum, and will stop. So this is another way to actually go about repetition in flowchart and Pseudocode, and this, both of these have the same meaning. Okay. So and one more program I'd like to do is grading. Okay. So this is actually a lot of fun to make. So say I want to make a grading system with A grade should be given to anyone who gets 90 plus. B is out of 100. B should be given to anyone from 80 to 90. C should be given to anyone from 70 to 80. D should be given to anyone from 60 to 70, and E from 50 to 60. Okay. So this is suppose the grading system that we're trying to make. So how we will go about this is, I will first input the grade, okay, and I will say if now here we have to put a huge if else condition. So watch how I do it. If grade is greater than or equal to 90, then it should print A. Now I will go into the else. So otherwise, now see, again a common mistake that happens is if I do this. Now, why this is a common mistake is because now, like the same program for the age one that I had made. over here, if I enter my grade something like say 95, it's going to print A, B, C, D, and E. It's going to print all of them together. Because why? It'll first go check grade is greater than 90, 95 is greater than 90. Okay, fine, print it. Then it will check if A is greater than or equal to 80, 95 is greater than 80, so it will print B, it will print C, it will print D, and it will print E. So that is again a flaw in your algorithm. So how you can make it right is by doing what we did before, adding a else condition. So else, else, um, else, if then this comes down. Okay, so now what I have done here is I've just changed it a little bit. I've just added else after each. So the thing is, if my grade is greater than 90, it won't check the rest of the conditions as it is. It'll just print A and end the program right there, right? But if it is not greater than 90, it'll check B, it'll check C, it'll check D, it'll check all of these grades until it finds the right grade. So this is another interesting program. So the thing is now I have taught all of you how to write these programs, but now ball is in your field. You all have to practice. The more questions you can solve based on these, better you will actually grasp the concept and understand. And the better you will be able to write such codes and such pseudocodes for your programs and whatever problems you're solving in computer science. Because programming is a lot of fun, and this is just the very first milestone. So, I would recommend you all to do this very nicely and thoroughly and practice a lot of it so that you can actually be very comfortable with programming. Because if you understand this, you will start to find programming a lot easier than you normally would. So that's the end of our video for today. If you liked our video, please like the video and feel free to comment down any feedback you might have or any questions you have regarding today's lesson. And please subscribe to our YouTube channel and do check out our website. The link of the website is in our description below. You will find everything I explained today in the website right there under the CBSE section. So do check it out and thank you for watching. Bye.